Okay, so the proof I have to do today is, it says suppose that A and B are real numbers. Prove that if if A is less than B and B is less than 0, then A squared is greater than B squared. I don't think that proof can be correct. I think it's probably not be correct. So going by the logic that was taught in the book, how to prove it in the second edition, let's look at our givens. So what do we have? We have that A and B belong to the set of real numbers. Then as well, because the statement is actually a P then Q statement, which means that our P can also become part of the givens. So we can also put that A is less than B is less than 0. A is less than B is less than 0. Oh, actually, it can be true because they are negative numbers. So maybe possibly, because for it to be lesser than it. So if we think about, and I think it's always also, so but before I get to that, so we can have a goal, and then the goal is to show that A squared is greater than B squared. So, I think it's always good to have kind of like a geometrical interpretation of the problem. I don't know if geometrical is the word, but basically I would say, a visual understanding of the problem. So if we think about a number line, this is not a proof, this is just a way to think about it. And we say this is our 0 point. And so we have -1, -2, -3, -4, -5. So this is the order of increasing. So it increases in this direction and it decreases in this direction. It decreases in this direction. And so what we know is that both of them belong to real numbers. Real numbers are, I've forgotten what the definition of real numbers are. I believe that they are positive and negative. Are that all numbers? No, those are integers. Integers are positive or negative whole numbers. Real numbers, I think, are the counting numbers. I can't, well, let's just say they are not imaginary. So, in this thinking about it, then it then falls to, if we just use an example, for instance, and this is not really proofs by examples, it's just kind of figuring it out. So -5 is less than -4, for instance, and so we can put this is less than -4 squared, and then we have that 25. 25 is greater than 16, because the idea was that A squared would be greater than B squared, being that A is less than B. So -5 is less than -4, and then, so at least by our calculations, but because this is not an exhaustive proof, we have to actually put up a proof that actually supports well, at least all cases in some kind of sense. So I'm thinking, how do I do that? How do I do that? How do I do that? Do I do a direct proof? What does it mean? I think what I have to do is maybe a lemma. I think it's called a lemma, a supporting theorem. What does it mean that A is less than B? What does it mean that A is less than B? I don't know. Do we say that there is a number C that is greater than A but less than B? Is that what it means? Because we can't use it, because they are not necessarily consecutive. Or we can say as well, I think this definition could work, but I think another definition could then be, we can say that A plus X is equal to B. That's what it means. That B is greater. That is, when we add something to it, we can achieve that. So I think these are two definitions. So if we go by the second definition, so let's see. I think I'd want to go by the second definition because I think I see a direct path to do a direct proof. So then, to do the actual proof, it will be A squared is is greater, pardon moi. Oh God, let me just wipe that off. A squared is greater than B squared, And so we have said that our b is a plus x. So we have that that's a plus x squared, and then that's a squared is greater than a squared plus 2ax plus, I don't even know where I'm going with this, but I guess this is rough work. Maybe okay, let's just go plus x squared. And so I guess we can subtract. Okay, so we bring this over to this side. We have that 2ax plus x squared is greater than 0. We can bring, I guess we can cancel the x, so we can cancel x, and then we have that 0 equals 2a plus x, and we can have that x you can have that x is greater, how does that work? Let's just, so this will be minus 2a, so x is less than minus 2a, because it is strictly, this is not, x is less than minus 2a. This just seems like it's taking me into a rabbit hole. I kind of think that I'm on the path of the proof. If I use the first definition, I think both definitions actually work. This is more intuitive, to be honest. But I'm trying to figure out the first definition. It means that there is a value c. When I say that a is less than b, it means that there's a value c that is between a and b, but it is greater than, wait, I think I wrote this wrongly. This should be c is greater than that, but is less than that. I wrote the direction wrongly. So where would I bring this c in is the question now. I mean, I just don't get. So that's why. So this second one feels more intuitive, that there's a number that I add to a to give me b, and then we substitute that in here, and then we whittle it down to that x is less than minus 2a. X is less than minus 2a. Oh, I think the consideration for the final step of the proof would then be that, based on the potential value of x, because if x is less than minus 2a, that's interesting to think about. I'm thinking that there will be a value that if x is a certain value, then the proof doesn't work, because maybe x is too small or x is too big or something like that. But minus 2a, that seems ridiculous if you ask me. If we said it's 2a, noting that this is possible, this is going to be a negative number. Maybe negative is not the only possibility, but let's say it's going to be a negative number. If we this sign only changes when you divide by, I think, a negative. So since we're not dividing here, so if we say x is less than minus 2a, what does that mean? Oh my, x is less than minus 2a. Okay, let's think of 2a first. That's double of a, then negative. This a is negative, and so if we have another negative, it will kind of add up, and then it will make it lesser. Would that increase it? So let's do a test. So look, going back to our number line, if I have minus 5, and it says that x is less than minus 2a, So, oh, okay, okay. Oh, this becomes positive. Then x is less than 10, for instance, in this case. Yeah, I don't see how that helps me. Yeah, I think I have to go do some. Okay, maybe I can ask ChatGPT and it can guide me what I need to do. Yeah, blah blah blah. Okay, so I'm trying to solve a problem where it says that suppose A and B are real numbers, prove that if A is less than B and B is less than 0, meaning that they are negatives, then A square is greater than B square. So, how am I supposed to go about this problem? I have an approach that I'm already going by, but how am I supposed to go about this problem? So I just didn't give it my own solution because I don't want it to be biased. I just want, so you are given that a a is less than b, and that both of them are negative. Well, I mean, if b is less than 0 and a is less than b, they're there. So rewrite the inequality in absolute terms. The absolute values are positive, and so we have a is great. The absolute value of a is greater than the absolute value of b, because when you take the absolute value of a negative number, it reverses the order of the inequality, kind of like the division thing. Then square both sides. Since the absolute values are always positive and squaring preserves the inequality for positive numbers, we get. Oh, okay. So basically, they got the final form. Are there any other approaches? So, for instance, what I started doing was I considered a number line and then considered that A will be further down on the number line because it's less than B, and then I considered that X. Then I considered that two definitions for what it means that A is less than B. I considered that there is a number C between them that is greater than A but less than B. Then I considered, and I went to the second definition that that means that there is a number X that when I add to A gives me B, so, but that just led me down a pathway where I got that X is now less than minus 2A. So I don't know, was that a whole confusion, or is there another way to get to the proof? Like, I understand the simple proof that ChatGPT gave here, but I'm trying to understand. Oh, it says I'm on the right track. Let's refine it a bit. So I understand the proof that it gave. The proof is very simple and straightforward, but that's the thing about proof. Sometimes you don't have the lemmas, which are like corollaries or theorems that you need to actually prove something. So you don't know whether you are right in, choosing a certain frame of thinking or stuff like that. So in this case, I just didn't know this stuff about the inequality that when you reverse the when you what's it called, when you do the absolute of the terms, that you actually get a reversal in the inequalities, because it's more or less kind of like you're dividing by a negative, and then when you square both sides you actually get so we just get the final form. But it says that I was on the right track. Let's refine it a bit and explore another way to reach the proof. So it says that since there exists a positive number, so x must be a positive number. Yes, x must be a positive number, and that is what we got actually. And that is what we got actually, that x was a positive number when we did that. Where x greater than 0, where x is greater than 0, so we had b. Yes, we also had this in our notes, where where x is greater than 0, that is because a is smaller. So the idea is that the idea of this step is that let me just go to my notes. The idea why, so for instance, if a was minus 5 and b was minus 4, the idea of a plus x equals b is that I should have minus 5 and then I should add a 1 to it, which then makes it minus 4, so that, because you have to move up on the number line, so it has to be positive. So that's the idea of that. Then I think I think it's using the canvas, and so we square both sides. Okay, since a is greater than 0, the term 2ax is negative because 2ax is, yes, and both a and x are negative. However, x squared is positive, meaning wait. We agreed that x was greater than 0 now. 2ax is negative because both of them can't be negative. If both of them are negative, then this can't be negative. X squared is positive, meaning that either I'm not getting what it's saying here, or it's just trying to bamboozle me and make me feel like my answer was correct or my method was correct. Because number one flaw that I see here is now saying that 2ax is it says 2x is negative, which is true because a would be negative, but x is positive. It tells us that it tells us that, but a and x cannot be negative. However, x squared is positive, meaning what? Is less. How did we jump from this step to b squared minus a squared? I understand how they now got to the final point. Let me ask it. So that step 3 makes no sense at all. I understand the rearranging of the equation, but number one, 2ax is definitely supposed to be negative, but a and x are not negative. A is negative, but x is not negative. We agreed that x has to be positive. That's what we agreed from the start, because it's a number that's been added up. And then, so x squared is positive. So, but how does that now lead to an inequality back? How did we get the inequality back? How did 0 even come into the equation? Yeah, so there's a lot that I don't understand, and this is what I literally just do. I hope I just don't run out of ChatGPT credits. Okay. So expand the square. Step 3, rearrange the equation. Now let's analyze the right answer. X squared is always positive because squaring a real number gives a non-negative result. Is negative because a is negative and x is positive, so their product, yes, that's correct. So x squared is positive and 2x is negative. Their sum depends on their magnitudes. However, notice that 2ax plus x squared, we draw out the x. Since a is less than 0 and x is greater than 0, the 2a plus x term is negative. So that means that, so for instance, we have that will be like 2 times minus 4, that's minus 8 plus 1, that's minus 7. This is probably not the best way to think about it, but for sufficiently small x. So the whole product remains negative. Oh, okay, so I get what they're doing now. I get what they're doing now. Or I get what ChatGPT was trying to explain. So I didn't need to go this route, but I had the right idea. I didn't need to go this route, but I had the right idea. So the idea is we continue from our second definition. So from our second definition, we have that a plus x equals b. What we do next is that we square both sides. So a plus x squared equals b squared. Then we get a squared plus 2ax plus x squared equals b squared. And so we bring over the a to the other side. So we have b squared minus a squared. I'm just swapping them. The equal operation is commutative, so it doesn't matter on which side they are on. Or is that what commutativity means? Anyways, then we have 2x plus x squared. And this is where the interesting thing about proving theorems comes in, because you almost have to kind of manipulate things to get to the answer, but it's not really manipulation. You just have to really understand, like, in depth, the problem and the solution that you're bringing forth. And so what they are saying here is now that you have to notice that 2ax plus x squared is also, so we can put like a but, is also x into 2a plus x. And so what we notice is that x is greater than 0, but 2a is less than 0 because a is less than 0. So this whole term, so the entire term 2ax plus x squared is less than 0. Yes, because it's negative. That's what we mean. Because So if this was a was minus 4, then this would be minus 8. Then we say 1, for instance, here, because we want to take it to pardon moi. If this was 5, I wanted to take it to b being 4, then this would be this, and this would be minus 10 plus 1. This would be then yes, minus 9, and then this is positive, so that would just be 1 times minus 9, that is minus 9. And so it tells us that this whole term is less than 0. So if this whole term is less than 0, what it then means is that, so if I say that x equals y, so this is the kind of reminds me of the zeroth law, I think, of thermodynamics or something like that, that if A equals B and B equals C, then you have that A is equals to C. So we can compare those qualities here. So if x equals y and y is less than 0, so then it follows by those is that, I don't think that's a transitive property. I can't remember what property that is. So basically the qualities of y also transfer onto x. I hope that's correct. I would ask ChatGPT. So it then means that x as well is less than 0. Yes. And so applying that intuition, then we have that b squared minus a squared is less than 0, and then we have that b squared is less than a squared, or that a squared is greater than b squared. And this is what was required. Oh, that's nice. So I want to ask though about that last part. So this is good. The part that I don't understand though is that how does it translate to the fact that just because the 2ax plus x squared term turns out to be negative, that is less than 0, how does that then transfer to b squared minus a squared? Is it a property where if x is equal to y and y is less than 0, then x also is less than 0? Is that the reasoning there? And what is the name of that property? So let's see. Yes, your intuition is correct. The reasoning resides on basic property of equality and inequalities. If x equals y and y, okay. So this follows from the transitive property. Yes, I knew it was. I kind of knew it was the transitive property of inequalities, which states that a equals b. If b is less than c, then also a is less than c. In our case, we established that we show that this term is less than 0 by the transitive property. Means that, and so that simplifies to that. Awesome, awesome, awesome. So I solved the proof. Nice.